Lesson 2. This is Algebra 1, Chapter 6 from the Structures and Methods book, which is one of my faves. And here is Chapter 6, deals with fractions, simplifying fractions. We're going to sort of start off relatively benign and then work towards the more complex and complicated ones. Something that I want you to see, which is really good, and this is really difficult for you to maybe recognize it in this fashion. It says x plus y over x plus 2 does not equal y over 2. These x's do not cancel. You can't cancel cross addition. So you must factor to find common factors to cancel. You can only cancel when they're multiplying. So for instance, if we have something like 2x plus 5 over 10. These can't cancel. The 2 and the 10 cannot cancel. A lot of students think that you can cancel this and you get x plus 5 over 5. And then maybe they even cancel the 5s after that and just left with x. That does not happen. You can't, doesn't work that way. The only time we can cancel is when we are multiplying. So things that can cancel are things like if we have 2x over 10, because 2 times x over 2 times 5, and then we can cancel those because it's multiplication and you end up with x over 5. So that's why they say you want to find a common factor. Factoring is turning it into multiplication, a product of two things. So as you see in these examples, they're going to factor and then they're going to cancel and they're going to simplify. So we'll go over a bunch of these. So we look at the numerator independent of the denominator. We're going to factor each of those. So my 3x minus 3y, I see they have a common factor of 3. And I'm going to factor out a 3 from both of those. We factor out the GCF. So 3x prime factorization, just in case you forgot. 3y is negative 1 times 3 times y. So we see the GCF is 3. That's that. If we take the GCF, notice that we're left with x, and we are left with negative y. So that's where we get those terms from. And then 9 we can break into 3 times 3. You don't have to show that, and those will cancel. And so my final answer is x minus y over 3. And that's our goal here. So we're going to factor out a 5 from 10m. We get 2m, minus 3n over 5. The 5's cancel. You're left with 2m minus 3n. Those are unlike terms, so we can't simplify that any further. We'll factor out a 4. That leaves us with a minus 5. And then we have a minus 5. Now, it is a quantity, so we could actually cancel this entire quantity. So we can't cancel them independent of each other, meaning I can't cancel the a's, but I can cancel them as a combination. So as long as it's multiplying this 4, that works out just fine. All right, so that leaves us with 4. So there are some nuances here. So the more we do, the more familiar we are with what they try to do and how they simplify, how they want us to factor and simplify. So we'll factor out a 4. The n plus 6 completely will cancel, and you're left with 4. We'll factor out a 2. We get n minus 9, and we will cancel. We'll factor, we are not going to factor anything out of the numerator here, but we'll factor out a 3 from the denominator. which gives us 2m plus 3. And this is a tricky one, so you get 1 over 3. A lot of students will just say 3. They'll throw it up in the numerator. That's not the case. It stays in the denominator. 3 is in the denominator. It needs to stay in the denominator. And when you cancel, you're canceling a value of 1. So 2m plus 3 over 2m plus 3 equals 1. That's why you can cancel them. We'll factor out a 6, you get x plus y. Factor out a 6, you get x minus y. The 6's cancel. You're left with x plus y over x minus y. Those cannot cancel because they are not identical and they're being added and subtracted. We can't cancel the x's. We can't, that doesn't equal -1 or anything of that nature. 3w plus 5 has no common factors. We'll factor out a 3. We get 3w plus 5. Those cancel. And again, you're left with 1/3. We can factor out a 4. M minus n. We'll factor out a 4. M plus n. The 4's cancel. M minus n over m plus n. That's my answer. So here now we're going to we'll factor trinomials or some of those special ones, difference of squares or binomial squares or trinomials, a times c. So in the numerator we'll factor out a 3. We get x minus 3. Denominator, 2 terms, subtraction, both are perfect squares. So this is the difference of squares, which produces conjugates. And the x minus 3 cancel. You're left with 3 over x plus 3. And that's your answer. Those 3's cannot cancel. The 3 in the denominator is being added. So that can't be canceled with the numerator. Factor out a 5, y plus 6. Well, that's the difference of squares again. 2 terms. And you should recognize those. Those aren't things that you should be hemming and hawing about. Those should be recognizable. You should know all difference of squares. You should know it quite easily, as should you with a binomial square for that matter. So numerator, we're going to see that that's the difference of squares, and we should know what the conjugates are that make up that difference of squares. B plus 2 cancels. We're left with b minus 2. Difference of squares, x minus 7, x plus 7. You have x plus 7. Those cancel. X minus 7. Factor out an 8. You're left with n squared minus 9. Factor out a 4. You're left with n minus 3. We notice that this is the difference of squares, so we can still factor that. Let's put it below it. So that's n minus 3, n plus 3 over 4 times n minus 3. The n minus 3 cancels. The 4 and the 8 cancel also. And you're left with n times the quantity n plus 3. We'll factor out a 5. That is going to give us 3c plus 5d. That is the difference of squares. Now we can factor. Let's factor a 10 out of there. And we get 9c squared minus 25d squared. Now this is the difference of squares. So we have 5 times 3c plus 5d over 10 times the quantity 3c minus 5d, 3c plus 5d. And not only the 3c plus 5d, but the 5 and the 10 simplify. So we're left with 1 in the numerator, 2 times the quantity 3c minus 5d. We wouldn't distribute it back out. We don't need to. We can just leave it factored. 4xy and then we can factor out an xy, and that leaves us with x minus y. The x cancels with the x, the y cancels with the y, because these are all multiplying each other. And that leaves us with 4 over x minus y. Factor out a 3x. You're left with x minus 2, 3x cubed. So the 3's will cancel. This x will cancel with one of those. And that leaves us with x minus 2 over x squared. They cannot cancel or simplify. I'm going to do I'm going to do a times c. Since the coefficient is 1, I should be able to see that factors of 10 when subtracted equal negative 3 is going to be minus 5 and plus 2. That's the difference of squares. So honesty check. Let's see where you are. Can you measure? Here's a measure. Are you able to factor that numerator mentally? Mental math. If you're not, you should. That's just the realities of it. You should be able to look at that and do it that fast. That's where you need to be. Now, this is interesting. So some people might check to see if it's a binomial square, but this sign must be positive for binomial square. So since the coefficient is 1, we can still do factors of 36 when subtracted equal 5. So A, factors of 36, let's do 8 and 3. We need more negatives than positives. 8 times 3 is not 36 though, sorry about that. Let's do 9 and 4. That was real interesting. You must have been like, what? What is he talking about? My bad. 8 minus 9, 8 plus 9. And let's cancel the negative 9's, and that leaves us with a plus 4 over a plus 9. Sorry about that. Now this one, okay, it's probably worth it to do a times c. Some students will be able to do that, but we'll do it. 1, 12, 2, 6, 3, 4. Signs are different. Bigger's negative. Right? Signs are different. Negative means different. And then we look here, and that's the bigger of the two factor pairs. So we get negative 11, negative 4, negative 1. This is equal to my middle. So I'm going to use these two, and that's going to be 2w squared plus 3w minus 4w minus 6 all over. We'll factor that out. We can do that step. And let's do factor by grouping for these. We'll factor group, factor group. We'll factor out a w. We get 2w plus 3. We'll factor out a negative 2, and we get 2w plus 3 all over 2 times w minus, whoop. These are the same, so we know we did that correctly. We're going to factor that out. That's a 2w plus 3, and that leaves us with w minus 2. W minus 2 over 2 times w minus 2. The w minus 2 cancels. That leaves us with 2w plus 3 over 2. Okay, well, I'm going to do it. It's 2x, it is 3, and then it is 1 and x. That's positive, that's negative. And the bottom one we should be able to do mentally is going to be plus 3 x minus 1. So that's where you really want to get to. If you're in Algebra 2, you should be able to look at that and see how to produce 5x as your middle. That's your outside 6x, negative x. That's how we get the positive 5x. This is going to give us 2x squared. This is going to give us negative 3. 2x squared, negative 3. All that should be done mentally. But if you need to do a times c, do a times c. 2 times 3 is 6. Factors of 6, 1 and 6. 1 subtract, or when the signs are different, equals positive 5. Whatever. We got it. Boom. Those cancel. 2x minus 1, x minus 1. The more time you put into your factoring, the easier your work is going to be. And this type of factor work is going to absolutely come into play. Were there restrictions? Did they? No. Oh, give any restrictions. Let's go back to that. Sorry. Give any restrictions. Wow, that was sort of straight up. We didn't even discuss that. So restrictions are when variables are in the denominator. We don't have a variable in the denominator. We don't have a variable in the denominator. Now we have a variable in the denominator. So something that we have to be aware of are what values can A cannot. This is a restriction. So when it says list the restrictions, A cannot equal 5. So this works in any other fraction except A can be any number but 5, because when A is 5, then we get 0 in the denominator and you can't divide by 0. So restriction, so the restriction for this one is n cannot equal -4. So it's all real numbers except for those. So the restriction is n cannot equal -6. The restriction is n cannot equal 9. The restriction is m cannot equal -3/2. -3/2. Yeah, -3/2. And all you're doing is you're setting that equal to 0. So you do 2m plus 3 equals 0 minus 3. 2m equals -3. Divide by 2, divide by 2. M cannot equal -3/2. Restrictions. Oh. Huh. How are they going to write that one? That's an interesting. Let's take a second here. What do you think that is? Let's look at that. That is 6-1. What problem number 8? 8. Let's look at 8. Oh, answers. Where's the answers? Answers given at the back of the answer key. Thanks. Thanks for that. At the back of the answer key. So let's see where. No, that's not the book. Let's see if we have an answer key for you. Let's see if we have algebra. Oh, that's book 2. Oh, no. Where's Mr. Max? I don't know where my worksheet is. All right, well, I'm not certain what the restrictions are for that one. I mean, was it X and Y, additional answers? That's not going to be chapter 8, though. Chapter 1, chapter 7, we're close. Is it, oh, maybe it's chapter 6. Chapter 6, oh, number 8, though. What? Chapter 6, what? All right, well, let's go, maybe, well, let's look at some more pictures. What else did Mr. Mac scan back in the day? Well, that doesn't look like it. That looks like other work. 143, yeah. That's interesting why they wouldn't. Chapter 5. All right, well, we'll keep this open for number 11. We'll see what they write. Number 9, that's easy. It's one variable. So restriction restriction is going to be W cannot equal -5/3. And all we're doing is isolating from that. Restriction is, oh, here we go, 10. Yeah, of course. I don't know what the restriction are. M and N can't be opposites of each other? I don't know. Exclusion, yep, we call them exclusions also. So X restrictions is X cannot equal ±3. ±3, meaning it can't be +3 or -3. Even though we canceled that one out, we still know that it can't be a value. So the restriction for number 11, let's see what it says. 11. Oh, it's just +3, huh? Just 3. That's interesting. All right. So it's just, whoa. The restriction is what? +3, not -3, because that one stayed there. It didn't cancel. That's interesting. So it's just +3. What? Oh, -3. What if it's -3 though? Ah, you're squaring -3. Ho ho! So I see. So it's just 3 for this one. So that does come into play, but -3 gets squared in this specific situation. Got it. Sorry. All right. So again, restrictions is y is not going to be able to be equal to 6. And that's because of that one. -6 gets canceled, so that's not the case. Here is our denominator, restriction. Restriction is b cannot equal -2. Our restriction is x cannot equal -7. Our restriction is n cannot equal 3. Yep, these are good. Our restriction, oh, here's 2 variables. All right, let's see, this is 16. What do they say for 16 when you have 2 variables? Oh, okay. The restriction is c cannot equal 5/3 d plus or minus 5/3 d. That's very interesting. Okay, so, and that's this. So c cannot equal plus or minus 5/3 d. That's interesting. But the reason why we do plus or minus is because both of those, but that's getting squared. Who knows? This one's a hard one. Mr. Mac has never been really good with restrictions. Sorry. So this one, we're going to say, I'm going to say the restrictions is x cannot equal 0, y cannot equal 0, and no, x cannot equal y? Let's see. Maybe I just got good at it. X cannot equal 0, y cannot equal 0, x cannot equal y. I said I wasn't good at this, and I just did it. Yeah. What's the reasoning behind it? Why? Well, we can't have x equaling 0 because those are multiplying. Y can't equal 0, and then I just solve for x, and you would add y, and x can't equal y. That's my thinking. I'm going to say restrictions are x cannot equal 0. That's a nice easy one. Restriction is A cannot equal plus or minus, nope, just +2. Yep. Should we check each of these? What number was that? 19 is 2. 19. Oh, now you do plus or minus 2. Why is it plus or minus 2? Why is it plus or minus 2? We're squaring. All right, plus or minus 2. Yeah, but minus 2 doesn't, that gets squared. I think that should just be 2. Who knows? Here we go. Next one, restriction is A cannot equal 9. Yeah, because 9 squared is 81. That would give you 0 in the denominator over there. Restriction is W cannot equal 2. Are we done here? Oh, was this the last one? Maybe this is, yep, I think we stopped here. So those cannot cancel. The restriction is X cannot equal 1 or negative 3. And we'll do negative 3 and 1. Negative 3 and 1. That is question 22. 22 is negative 3 and 1. All right, we're good. Now we have to factor. So same thing. We're going to rewrite. We don't like those when they're not in standard form. So 3n plus 2 n minus 3. We're going to rewrite this to n plus 3. And we're going to rewrite that to negative n plus 3. And then we're going to factor out because we can't have a first term negative. So it becomes 3n plus 2 n minus 3 over n plus 3. I'm going to factor out a negative 1, and I get n minus 3. So that negative 1 technically goes out here, and then these will cancel, and that's it. Oftentimes, so you get 3n plus 2 over negative 1 times the quantity n plus 3. Or you can pop that up, but you can just do it there. There's a lot of different answers. Let's see what they do. Do they keep it in the denominator? Negative 1. Let's see. This is 23. How do they want 20? Oh, they pulled the negative outside. Okay. And that can be the case also. So when you have a negative outside there, that needs to be distributed. So it's outside. You don't need parentheses. You can write it like this. You can write it like this. But if we moved it down, then we would have to distribute it to both of those. So just be aware. Or if you moved it up, you would need to distribute it to both of those. So when it's out there, it is yet to be distributed. We'll write this, x minus 4, 3x plus 4. We're going to rewrite negative x plus 4. We got 5x plus 2. We're going to factor out the negative. So we get x minus 4, 5x plus 2 in that denominator. X minus 4, 3x plus 4. The x minus 4 cancels, and we'll throw that negative out there. 3x plus 4 and 5x plus 2. As long as that is even with the vinculum, we're okay with it. X minus 5, 2x minus 7, negative x plus 5, 3x plus 2, x minus 5, 2x minus 7. We'll factor out the negative, get x minus 5, 3x plus 2. X minus 5 cancel, 2x minus 7 over 3x plus 2 with the negative outside of it. Okay, we're keeping it going. X minus 7, x minus 4, negative x plus 7, x plus 2, x minus 7, it's a horrible minus 7, x minus 4, factor out the negative, x minus 7, x plus 2. These cancel. You're left with the opposite of x minus 4, x plus 2. Factor. Now this is a binomial square. This is going to be x minus 5 quantity squared. And we're going to rewrite this. And then we're going to factor out the negative. And we get x squared minus 25 over x minus 5 quantity squared. And this is the difference of squares. So this becomes the quantity x minus 5 quantity squared over the opposite of x minus 5, x plus 5. And one of these x minus 5 is going to cancel with one of those two. And we're left with negative x minus 5 over x plus 5. Oh, I didn't do restrictions. Hi-ya. Hi-ya. Let's do restrictions, sorry. All right, restrictions are going to be, sorry, I'm so focused. N cannot equal plus or minus 3. Plus or minus. What number is that? 23. Plus or minus 3. N 23 plus or minus 3. Let's go! The restriction is going to be x cannot equal 4. X can't equal negative 2/5. I think that's it. Yeah, I'm pretty certain. 4 and negative 2/5. What's this? 24, 4 and negative 2/5. Good. All right. Well, at least we're getting these. Restrictions. X cannot equal 5, and it cannot equal negative 2/3. Yeah. Restriction. Oh, I didn't even box that. Boxing. Restriction. X cannot equal 7 and negative 2. 7 and negative 2. Let's check that one. That one might be a little iffy. 26. 7 and negative 2. Nothing iffy about that. I got it. I got it. Restriction is going to be x cannot equal plus or minus 5. Now it's being squared, so negative. I'm going to say it's just positive 5. Let's see. Come on, baby. 27 is just 5. 27. Nope. Both of them. I don't know why. That one I don't know. Because if I do negative, it's just going to squared. So it can, I don't know. Well, who knows? All right. Oh, I'm on back to where I'm supposed to be. So we'll rewrite this. We'll factor that. That's going to be 2, which is 6 and 4. Plus 4. And we'll factor out the negative, which makes x minus 6, and x minus 6, x plus 4. The x minus 6 cancels, and I'm going to write negative 1 over x plus 4 is my answer with a restriction. I'll remember to do everything. With my restriction of x cannot equal 6 or negative 4. I'm not even going to look. I know it's right. This one maybe not so much. Is that green? Sorry. Oh, yeah, we got lots of problems left. Okay, long video. We have a minus 3 quantity squared over negative a squared plus 9, which can be written as a minus 3 quantity squared. Factor out the negative, you get a squared minus 9. That's going to be the difference of squares. So we get the opposite of a minus 3, a plus 3, and one of these cancels with one of these. And we'll put the negative up in the top and get a plus 3 is my answer. And my restriction is going to be a cannot equal plus or minus 3. We're going to factor out I do it in green after the restriction. Factor out a 2, we get n squared minus 36 over, we'll factor out a 6, we get n plus 4. That's the difference of squares, n minus 6, n plus 6. 6 times the quantity n plus 4. Not bad, 4, 6. 6 times 6 is 36. Mr. McGosland. Those cancel. That's going to cancel. That's going to cancel. And we're left with n minus 6 over 3 is my answer. And my restriction is n cannot equal negative 6. Yes. Yes, we love it. Negative x squared plus x plus 6 over, that's the difference of squares, which makes conjugates. We're going to factor out the negative. You get x squared minus x minus 6 all over x minus 3, x plus 3. We're going to factor this mentally. That is the opposite of, we're going to do x minus 3, x plus 2, x minus 3, x plus 3. My x minus 3's cancel, and I'm left with negative x plus 2, x plus 3. With restrictions of x cannot equal plus or minus 3. We will rewrite this in standard form. We see that that is the difference of squares. Factor out a negative. X minus 2, x plus 2. Nope. We see that we can factor that. That's going to be the opposite of. And that's going to be factored of x minus 5, x plus 2. That's going to be x minus 2, x plus 2. Those will cancel. We're left with the opposite of x minus 5, x minus 2 is my answer with restriction of x cannot equal plus or minus 2. We've seen that one before, 12. So, not green. That's going to be 2w, and that's going to be w, and we're going to make this 3 and 2, and that's going to be negative. That's going to be positive, and we're going to factor out a 2, and the w minus 2 cancels, and we're left with 2w plus 3 over 2 with a restriction where w cannot equal 2. We'll factor out a 3x. That's a fun one. X, too bad we don't do that in the denominator. That would be really fun. X minus 2 over, okay, you might want to do a times c, but Mr. Mac's going to try that. So we're going to do 7. That's got to be like 2 and 3 x, and that's That's 2 and 5. No. That's 6 and 10. No. Oh, maybe it is 6. Let's do 6 and x. This is why you don't do this method. And then we do 5 and 2. And that's going to be minus plus, because this is 12, negative 12, positive 5. Negative 12x, positive 5x gives us our negative 7x. That's how we did it. But see, it takes time. It takes too much time. So it's not very efficient. But you can still use it. Then we get 3x over 6x plus 5 is our answer, with a restriction of x cannot equal 2 and it cannot equal negative 5/6. Number 35, we're still going to use mental math. Well, that's 2, oh yeah, 2n, 1n, 3. That's going to be positive, that's going to be minus. We're going to do, signs are different. Well, we're probably going to do 2n, 2n. That's going to be 5, and that's going to be 1. Yes. That's going to be positive, that's going to be negative. 2n minus 1 cancels. We get n plus 3, 2n plus 5, and that's my answer. My restrictions are going to be n cannot equal 1/2. Got it from there. And n cannot equal negative 5/2. Got that from there. So we just set it equal to 0. Good. 36. I think it might be the last one. 2y and y. That's going to be 3 and 1. Signs are the same. Both are negative. We're going to factor out a negative 2y. And that's going to give us y minus 3. Because I'm rewriting this. I rewrote this as negative 2y squared plus 6y. Factor out the negative 2y and we get y minus 3. That's what was happening. Y minus 3 cancels. We're left with 2y minus 1 over negative 2y is my answer, with restrictions of y cannot equal 3. It cannot equal 0 because of the y by itself, and that's it. Not done. Let's do 3y. Let's do 2. Oh no. Oh no. Tricky. Signs are the same. That was a tricky one because it's 5. 6y. No, that's going to be 3y. 2y. That's going to be 2. That's going to be 1. That's going to be negative. That's going to be positive. Cancel, cancel. Equals y minus 1, 2y plus 1 with restrictions. Y cannot equal negative 1/2. That's from here. And y cannot equal 2/3. That's setting it equal to there. Every time I keep thinking we're on the last one. Factor out a 3, you get x, factor out a 3x. That gives us x minus 5. Factor those, that's going to be, that's easy, 3x, x, 5, 1. Signs are the same, both are negative. And yes, that's how fast. So when we check here, I shouldn't be explaining how you do A times C. You're just checking your work against mine at this point. There's no learning here. You're looking at these problems. You're coming here to check your work against my work. So you're pausing the video, you're looking at the problem, you're doing the problem, and then you are checking to see if you get the same solutions. So this is not sort of, we're past that point of, that was earlier problems. By number 38, you should be doing as fast as I am. Or you should have knowledge of what I'm doing and know that when I talk about the restrictions, that I'm setting this equal to 0, which would mean x cannot equal 1/3, and you're setting that equal to 0, which is 5. So that's how we're getting those restrictions. And that really was the last one. All right, chapter 6-1. Lots of work there. Good practice. Enjoy.